So we have written the null hypothesis, alternative hypothesis, test statistic formats already written, and the calculations are all done. So I'll just write the calculated value. Next, you have to fix alpha and write the degrees of freedom. So degrees of freedom is generally m minus 1 into n minus 1. M indicates number of rows, n indicates number of columns. In the given question, there are 2 rows and 2 columns. So it is 2 minus 1 times of 2 minus 1, which is 1 into 1 is equal to 1. Now, if you look into the question paper, see what are all values are given to you. So if you look into the first value, given table value, you have chi-square 0.01 comma 1, that is equal to 6.634, and then you have chi-square 0.01 and 2 degrees of freedom, I guess. So that is not clearly visible. So these two are given. Now our degrees of freedom, what we have computed is 1. So I have to select the table value for 1 degrees of freedom. So this is the general way. I'll give chi-square alpha comma degrees of freedom, or degrees of freedom comma alpha. So they have given the table value for 1%. So I'll take alpha as 1% and I'll conclude. So what do we have? We have observed value as 0.852, and our table value, which we generally call as K2, is this, and our observed value is far below the table value. Therefore, we reject the, do not reject the null hypothesis. This is my K2, 6.63, but my value is somewhere here, 0.85, which is in the rejection region. Therefore, H naught is not rejected, or you could say H naught is accepted. So we are telling that gender and result are independent. So this is the case for that particular program. You cannot generalize this. Whatever the course, or the whatever your population or the sample you have extracted, it is true for that population only, not the general case. So this is how we do a chi-square test for independence of attributes. Any doubt here? Now I have shared one more question paper. You can solve that problem also in your free time. The second paper is of the previous year, I guess. Last batch paper, I guess this is. So again, you have the question in 11B. Again, this 2 cross 2 only. So try it. Post your answers in the group. I will correct it. Okay, so we have come to almost end of the statistical techniques. There is one more technique called as ANOVA. So we'll just look into the assumption and how and where the test ANOVA is used, what are its requirements. That we'll do tomorrow, and tomorrow will be the last class. So today, as said, we'll talk about the question paper. Okay, so much of the questions will be from the statistical part, that is block 2 as well as block 4. And you can have theory questions related to research and research methodology, which is block 1 and block 3. And you can see the most of the questions are based on what are the types of data gathering methods, and then you have roles of research, researcher, different types of research, report writing, questionnaire technique, census survey, and sample survey. So you can just look into the question paper and see to which part you must concentrate. But yeah, the hard paper 2019 only H statistics there, and mostly as discussed, the concepts are almost covered in the sessions. Okay, look into next paper, variable C, role of researcher in a research, and then sampling and non-sampling errors, statistical hypothesis testing, research, writing and publishing a research article, types of research articles is there. probability and non-probability samplings. And then, so much of the concepts are statistical concepts only. Okay, so which question paper shall I take to solve? I'll solve one paper completely. The other one, you can take it as a homework and you can try in your free time. And I'll be just looking into the practical aspect of the paper. Question paper ಮಾಡಬೇಕಾ ಮಾಡ್ತೀರಾ? Try ಮಾಡ್ತೀರಾ? So I'll leave question number 4 to you. Compute mean and standard deviation. This is August 2019. So let me take fifth one. ಯಾವ್ದು ಸ್ವಲ್ಪ ಕಷ್ಟ ಅನ್ಸುತ್ತೆ ಅದು ಮಾತ್ರ ಮಾಡ್ಕೊಡ್ತೀನಿ. ಇದೆಲ್ಲ ನೀವು ಮಾಡ್ಬೋದು. Correlation, regression, ಅನ್ನೋ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಕೇಳಿದ್ದಾರೆ ನೋಡೋಣ. Okay, so let me take the question regarding a proportion as well as a Poisson distribution. Okay, so question 5. What is a PMF? Given example. So PMF stands for probability mass function. A probability mass function is a probability function such that the total probability is equal to 1 across all the values of x, and every probability value is greater than or equal to 0. Roughly lies between 0 and 1. Example, you have binomial PMF, which is NCX, e to the power of x, q to the power of n minus x. You have Poisson PMF, which is e power minus lambda, lambda power x by x factorial. And whenever you write a PMF, you complete it with respect to the range of the variable as well as the parameters. So here the variable is x. It takes value 0 to n. N and p are the parameters, p lying between 0 and 1. And in Poisson, x takes values 0, 1, so on up to infinity. Lambda is the parameter which is greater than 0. The average number of decayed teeth observed in patients is 2.3. Use suitable PMF, compute the probability that a randomly selected patient will have more than 2 decayed teeth. Okay, so some information is given. So bracket allow e power minus 2.3 ಕೊಟ್ಟಿದ್ದಾರೆ, and we use e power minus lambda when it comes to Poisson distribution, and we have our variable x is equal to number of decayed teeth. So until and unless you see and observe how many decayed teeth could be there, you cannot give a maximum count. You cannot say 32 is the maximum teeth, so at the most all could be the case, but in practical situation that doesn't happen. So we just leave it as 0, 1 to a particular number, which we generally say infinity mathematical. So this is clearly Poisson, and Poisson has one parameter which is lambda, and in a Poisson distribution lambda is nothing but average. And for a set of large patients, what you have observed in the past, you have come across an observed value for lambda which is 2.3. On an average, 2.3 teeth are observed to be decayed per patient. So this is the information given, and for the calculation we need e power minus lambda, so that's why that is given in the question. Compute the probability that more than 2 decayed teeth will be observed in a patient. So more than 2, we have taken number of decayed teeth as x. So more than 2 indicates x greater than 2. Now x greater than 2 indicates the probabilities for x is equal to 3, x is equal to 4, x is equal to 5, and so on. And this takes up to infinity. So we cannot sit and compute each and every probability. So what we use is, we use the technique of the complementary event. So any event is always same as the not happening of that event. And when you're talking about complementary, happening probability is 1 minus not happening. So this becomes 1 minus x less than or equal to 2. And the values for less than or equal to 2 are x is equal to 0, x is equal to 1, and x is equal to 2. Just compute the probabilities. So what is the PMF for a Poisson distribution? It is e power minus lambda, lambda power x by x factorial. So for a particular value of x, you will use this form to compute the probabilities. To avoid much of the calculations, I have used this form. So you can always remember this. For a Poisson case or any general case, any x greater than k will be always equal to 1 minus probability that x less than or equal to k. Whenever you want to avoid much of the calculations, you can use this form and you can obtain the probabilities. So this will be p of x equals 0. So when I put x equals 0 here, I'll get e power minus lambda, lambda power 0 by 0 factorial. Lambda is 2.3 and e power minus 2.3 is given. So that becomes 0.1003 into 2.3 power 0 by 0 factorial. 2.3 power 0 is also 1. 0 factorial is also 1. So the first term remains just 0.1003. Next we have p of x is equal to 1. So put x equals 1 here. You get e power minus lambda into lambda divided by 1 factorial. So this 0.1003 into 2.3 to the power of 1 by 1 factorial. And next it is 0.1003 into 2.3 power 2 divided by 2 factorial. Now simplify this, subtract the total by 1 and you compute the probability. So we're getting answer around 0.2895. So there is 28 or close to 29% chance that if I select a random patient, he will have more than 2 teeth decay. That chance is 28.95. So look into some more problems and master how to compute the probabilities for Poisson as well as a binomial case. So very simple problems like this will be asked. So you can use the second PUC book, whatever the book which you have downloaded, in order to have an experience in solving the problems on Poisson as well as binomial. Next, question number 6, an application of statistic and an estimate of that. What are statistic and parameter? Statistic indicates the function of sample values. Statistic is function of sample values like sample mean, sample variance, etc. Parameter is the population constant like population mean, population variance. Obtain an estimate of standard error of sample proportion. Now this is from the test statistic of z-test for proportion. Now to remember, yesterday I said if you have sample proportion, that sample proportion, the mean of sample proportion actually follows normal distribution with mean p and variance or standard deviation pq by n. So this standard deviation for a statistic is called as standard error. So this is what is obtained. If you know capital P and Q, you can use this form. So if your P is unknown, then you can estimate it from the sample value only. And then we call that as estimate of standard error. And that also was given in the class. And that is your PQ divided by N. The question says, obtain the standard error of sample proportion, which is P 0.6 with N is equal to 100. So what is the meaning of this question? Means you have selected a sample of 100 items. From those 100 items, you have computed proportion of certain attribute and that has come to 60% or 0.6. So if this is observed, what is the standard deviation of this particular statistic? Now to obtain standard deviation, I should know the population proportion, but that is unknown. We are talking about the estimate. That's why we are talking about the estimate. So this is just estimate of SE. So estimate na ನಾವು ಈ ತರ statistically cap ಅಂತ ಬರೀತೀವಿ. Estimate of standard error, that is square root of PQ by N. Q is always 1 minus P, so it is 0.4. So this is square root of 0.6 into 0.4 divided by 100. So always remember this, the standard error of proportion as well as standard error of the mean. So this is for proportion, and similarly for mean, we say mean of mean always follows normal distribution with parameters mu and sigma by root n. So that means your x bar has mean mu, x bar has standard deviation, which we call as standard error, sigma by root n, and for large n, only for large n, if sigma is unknown, you can use s is equal to square root of sigma x minus x bar whole square by n minus 1 to obtain the estimate of sigma. So this is called as estimate of sigma, and statistically speaking, that is called as unbiased estimate. So you not worry. So one problem could be on this case: mean and standard error of proportion, mean and standard error of sample mean. Okay, so next we have a t-test problem, and then chi-square was just done. Then you have problem on regression, Pearson correlation. So that I'll give you as a homework, so you can solve 12:30. We'll look into question number 14 and topics related to ANOVA in the next class, tomorrow, the last class. Now we'll look into this question number 10, t-test. So you have a t-test question given. So I said two problems will be there. One from the t-test for single mean and another one for a pair t-test. Next paper section CLE pair t. Try ಮಾಡಿ pair t, Pearson correlation ಎಲ್ಲ. So videos help ತಗೊಳ್ಳಿ, textbook help ತಗೊಳ್ಳಿ ಮಾಡಿ. So I'll wind up the session with this problem. Question number 10. What are t-tests? What are its applications? So t-tests are the hypothesis testing procedure used to test the mean or difference of two population means whenever a sample is selected from a normal population. And usually the tests are also called as small sample test because here we deal with samples of size less than 30. Applications: t-tests are used to test mean of a single population, difference of means of two population when samples are independent, and pair t-test. Those are the three types. The types are application here. Carry out a suitable t-test for the case: a sample of 20 rats, sample of 20 rats. So sample size, so you are selecting 20 rats were diagnosed for weight of their hearts, and the average weight is observed to be average weight. So for every rat you have selected, you are recording the weight of heart. So that is the variable here, and its average rate. So since I have taken x as the variable name here, so I'll use x bar. And why I'm using x bar? Because it is the mean for this sample. They are giving you the mean for the 20 rats what they have selected. So 2.25 grams with a standard deviation of 0.56 grams. If the weight is more than 2.5 grams, then a drug has to be tested on them. Is there any evidence to administer the drug to the rats? Okay, so what we have to do is we have certain number of rats under the group called as experimental group. Now, in the experimental group, we are testing the administration of a particular drug, and the drug requirement is that the minimum heart weight should be 2.5 grams. So I have a lot of rats in the experimental group, but I cannot select every rat in order to obtain the average, because that leads to no rats for the experimentation. So we have just selected 20 random rats, and their hearts are extracted and their weights are measured. And for 20 such cases, we have obtained the values to be 2.25. Now the question is, can we administer the drug? So we cannot take the decision just by looking into the values. As said, it is just for that particular sample. The reality is actually different. So what is the actual reality? That is what we are checking. So can we administer the drug? When do we administer the drug? If your mean is greater than or less than, weight is more than 2.5 grams. If the mean weight is more than 2.5. So in that case, we can say yes, administer the drug to the remaining rats. Otherwise, no. So we are testing whether the population mean is more than 2.5. Okay, so we say the mean weight. So mu equals mean weight is 2.5 grams. Mean weight has gone up to 2.5 grams. Why are we writing the hypothesis like this? So as said, we are, using the experimental set of rats. We are providing them with sufficient nutrients so that their body weight, heart weight, everything will go up, so that certain drugs, could be tested on them. So we have the notion that whatever we are feeding, that is useless, and whatever the behavior, the properties, body properties observed in the rat naturally, that is, still existing. And then whatever we have fed, that has led to this case, so that I can administer the drug. So that's why our hypothesis are mu equals 2.5 grams versus mu greater than 2.5 grams. And t-test formula for this particular test. So here we are applying t-test for single population mean. So this is the suitable test. Why single? Because they have just given one set of mean and standard deviation. Test statistic is t is equal to x bar minus whatever the value you observe in the hypothesis, that is 2.5 minus s by root n minus 1. So generally we take this as mu naught, and in the formula we write x bar minus mu naught. So x bar is given as 2.25, mu naught is 2.5, s is 0.56, n minus 1 is 19. So simplify that and write that as t cal value. Which is minus 1.9459. So now see the question paper to select alpha as well as the table value. So first step is observing the degrees of freedom. And for a t-test, degrees of freedom is n minus 1. So totally 20 values, 20 minus 1 is 19. Now select the t value given for 19 degrees of freedom. Now they have said use alpha equals 0.01. So whenever alpha is said in the question, mentioned in the question, please use that particular alpha only. So they have said alpha of 1%. So pick the critical values for 1%. I have first value is not visible clearly. Second value is for 1% and 18 degrees of freedom, I guess. The question paper 20 degrees of freedom. Okay, so they have given 0.01 20 is equal to 2.528 and 0.01 19 is equal to 2.539. Okay, so the select the value, table value to be selected as this, and here we are talking about a right tail test, so the value has to be considered as positive. 19 is the correct degrees of freedom, so don't take this number to compute. Now for a right tail test, if you remember the rejection procedure, reject the null hypothesis if your observed value is more than the table value. So reject H0 for a right tail test if your calculated value is more than k. So here our calculated value is minus 1.9459 and k is 2.539. So we are talking about a situation where my table value is on the right tail like this, but our observed value is somewhere minus 1.94, which is the rejection region. So H0 is not rejected. So we are telling the weights of rats have not improved. So it is same as what we observed prior or in the beginning of the experiment. So it is less than 2.5 or at the most it is 2.5. It is not gone above 2.5 grams. So the answer for this question, can we administer the drug? No, we cannot administer the drug. So for if we had rejected the null hypothesis, then we would have said yes, the average weight of the heart has gone up or gone above 2.5 grams. So you can administer the drug. Fine. So have some question papers, some problems. If possible, I'll send you 1 or 2 more question papers. So try them whenever you are free, and please post your answer in the group only. Okay, don't get the impression that my calculations are wrong, correct. Don't bother. So just post your answers in the group. Whenever I have a free time, I'll just look into that and I'll comment on those cases, whether it is correct or wrong, which step has to be followed, things like that. So we'll have a last session tomorrow and we'll talk about a topic called as ANOVA, analysis of variance, an important topic, and that also comes under the hypothesis testing procedure only. We'll see when do we use that particular hypothesis testing, then we will wind up the session. So hopefully only one session is sufficient for tomorrow. Let me